Hello, ladies and gentlemen, and welcome back. Today we're going to be talking about shape, center, and spread. Again, we're going to be doing these from various visual representations such as a histogram or a dot plot, primarily the histogram. Keep in mind that yes, we do have an assessment at the end of the month, and today I'm going to have you guys working on two things. You've got a worksheet that I want you to work on. Once again, you can print that out from the linked webpage, and there's a Math Excel for you to complete. Once again, all Math Excels are due by Friday at 1 o'clock. So let's get started. Shape, center, and spread. Their graphical displays are really nice for helping us to picture things, but patterns in the data, you kind of sometimes will have to find a way to describe it so that everybody can understand it. The basic ones that we talk about are center, spread, shape, and any unusual features. Okay, we'll kind of handle each of those in turn here. So now these are only to describe what are called quantitative data. Quantitative data are numerical data. You do not use them for qualitative data, for categories. Okay. Some ways of describing and some numerical data might be your height, your weight, or something like that. Qualitative data would be what country your ancestors came from. England, India, France, China, Japan, Vietnam. Those are categories. With numerical data, you can literally do the same spread between values, say 20 to 30, 30 to 40, 40 to 50, and nobody gets left out. But qualitative data, that's done literally just as classifications. So this is something that we use on our center, spread, shape, and unusual features. We use that for qualitative data. So let's take a look at a histogram. Now, a histogram, as opposed to a bar graph, histogram is a graphical display using columns of different heights. Each column represents a qualitative or quantitative variable. There is a big difference between a histogram, which is displayed here, and a bar graph, which is displayed here. This is going to be qualitative data, okay, as opposed to my quantitative data. Notice there's no gaps in here. But we don't have overlap between USA and India, UK, New Zealand, etc. Okay? These are by categories. These are numerical ranges. So a histogram will always be numerical ranges. Okay, moving on. Next, we look at the center of a distribution, which generally we describe as being at the median. Now we've talked about the median, it's the middle value. It's about half the observations are on either side. No big deal there, nothing exciting. Let's move on then. Spread. That's your distribution referring to the variability of the data. If the observations are covering a wide range, okay, we remember range from the last display, the spread is going to be larger. So we're going to take a look at an example right here. This is one that has less spread, 2.5 to 7.5. Okay, that's only 5 units in between the top and bottom. Whereas here, you've got more spread, running from 9 down to 1. That's 8 units, considerably more spread there. Next up, shape. And there are multiple types of shapes that we look at. So we talk about, first off, symmetric. Symmetric is something that's even on both sides. So we can say that roughly, it's not exactly, but generally, you would say there's symmetric data here. About as many people on this side, and about the same shape as that side. It's a little bit different, but we'll say that this is symmetric in general. Next, let's take a look at the number of peaks. Now, the number of peaks, you can say in this case, oh, there's just one peak. There's just one peak. Well, we call that instead, we call that unimodal. Okay, one peak. We also have the opportunity for bimodal and what are called multimodal. What do those look like? By the way, we generally like to have bell-shaped curves, but that's another matter. Unimodal, one high point. Bimodal, 2 points there. Multimodal, well, you can see 3 or more. Next, let's take a crack here at skewness. Now, some distributions have many more observations on one side on the other. When you have fewer observations on the right, we say that it is skewed right. Distributions with fewer observations on the left are said to be skewed left. So let's take a look at what these are. It's skewed left because we've got a bunch of observations here, but we've got a few little ones on this way. Skewed right means few little ones on that side, so it's going to pull. Once again, unimodal distributions, but they're being pulled by the smaller amounts. Now, skewness is described as the direction of the tail, okay? The direction of the tail over here. Because the tail, if you picture this as, I don't know, like a monster here with eyes and horns and crap like that, then you've got a tail on this side. You say your skewness is going to pull it in the direction of the tail, so it's skewed left there. And the last type that we talk about are what are called uniform distributions, where, yeah, you do have a high and a low, but honestly, most of them are almost all the same height. So when you've got a equally spread above the range, across the range, we're going to say that it has really no peaks. Yes, there is a high, but it isn't moving in a direction. Next up, we talk about the unusual features. Now, your gaps are going to be referring where there are no observations. And your outliers we talked about yesterday, where they differ greatly from the other observations. So let's take a look at what a graph would look like with a gap. So everybody here, and then we've got nobody in the middle, and then a bunch of people here. Well, there's a gap in here. Nobody's there. Here, we've got most of the people down in this level, and then you've got this one outlier that's performed way higher than everybody else. That's your situation for your unusual features. Okay, next, the skewness on the mean and the median. This is something that I would make sure I've got pulled down. The mean is going to be pulled towards the tail, always. Always, 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 always. Which is why, often, if you have a situation where there is some outliers there, you don't want to use your mean as your example for your measurement of centrality. You're going to say that I would like to use a median or maybe even a mode. Okay, the reason why is the mean will always be pulled towards the tail. My median for this data set is 5.36, but my mean is 6.71 because I've got a tail here. In the same way, I've got a median here of 13.64, but I've got a tail over here to the left, so it's going to pull my mean in that direction. Once again, wherever I have a tail, that's the direction it's going to pull things. So my mean in this case is bigger than my median, and in this case, my mean is less than my median. Okay, all right, moving on. Okay, symmetric, skewed left, skewed right, or uniform. I'm assuming for those of you that have pre-printed this, you're going to say, well, this is pretty obvious. I've got an obvious tail here, so it's skewed right. Here, okay, yeah, it's unimodal, but once again, I've got a tail there, so it's going to pull it to the left. Let's take a look at another couple of examples. Here, they're pretty much even. It's not 100% even, but it's pretty even, so I'm going to say it's symmetric. Whereas here, yeah, it's skewing to the right again. Next. Skewed left, yep, tail to the left, and, okay, they're not identical, but it's good enough that we're going to have to say that that's more of a uniform distribution. Okay. Next, doing an example where I want to look at this data set and answer these questions. Okay, take a look here. This is a survey of high school students when they thought that they would get married. And then this is a survey of seniors who are 65 and older. And we're going to compare the results. Okay, and if you need to back up, you might want to just sort of figure out where you are on the time on this and back it up so you can see the graph. So let's take a look. My question is, compare the shapes of the graphs. What conclusions can you make about the shape of the graph? Do me a favor, just hit pause on this and see if you can do some analysis. Okay, So what sort of conclusions did you come to, or what did you identify? Well, I'm really hoping that one of you, or at least you could have really noticed that there is this category with the seniors. I'm hoping that disturbs you a little bit because I'm really hoping that many of you are not planning to get married at this point between the ages of 14 and 17, but that's a matter for you entirely. Anyway, here's a nice write-up discussing this information even more so. Again, majority, it was symmetrical. Majority of them expected to get married between 26 and 29. Seniors was skewed a little bit to the right because, well, there were a lot of people that got married older. And also you've got, well, that group that was uncomfortable that was getting married younger. Okay, let's take a look at the second question then. We're going to compare the spread of the histogram. What conclusions can you make from the spread? Again, pause, and I will scroll back up so you can kind of take a look. Spread. I am truly hoping that you were easily able to mark that and say, well, many seniors were close to the same age when they got married, whereas the high schoolers tended to be more varied in their plans, and they do have the wider spread because of that uncomfortable group on the 14 to 17. Okay. I have links for each of these. If you have further questions, please shoot me an email and I will try and get back to you as quickly as I can. Until then, Math Excel and fill out that work.